In this lesson, we're going to go over the quadratic formula in the discriminant, especially as it relates to the SAT. So let's start with the quadratic formula. The quadratic formula is just some tool that you can use to solve quadratic equations, just like how you can solve a quadratic equation by factoring or through graphing. You can also use a quadratic formula. So this is a general form of a quadratic equation, ax squared plus bx plus c equals 0. And your a value is just your x squared coefficient, b value is just your x coefficient, and your c value is your constant. So for example, if I had 3x squared plus 2x minus 5 equals 0, then my a value is 3, my b value is 2, and my c value is negative 5. If I had negative 2x plus 5x squared plus 7 equals 0, then my a value is going to be 5 since that's the x squared coefficient. My b value is going to be negative 2 since that's the x coefficient, and my c value is going to be 7. So the a, b, and c values don't change even if the order is different. A value is always going to be your x squared coefficient, your b value is always going to be your x coefficient, and your c value is always going to be your constant. Now let's look at the quadratic formula. This is a quadratic formula. You'll have it on your formula sheet on the SAT, and here it is. It's negative b plus or minus the square root of b squared minus 4ac all over 2a, and a, b, and c again are just going to come from your quadratic equation. So let's take a look at an example. Let's say I had the equation x squared plus 4x minus 21 equals 0. And I wanted to solve this. One way I could solve this is by factoring. I want to find two numbers that add up to 4 and multiply to negative 21. So if you think about the factors of negative 21, the two numbers that we're looking for are going to be positive 7 and negative 3, because they're going to multiply to negative 21 and add up to 4. So if we factor this, it's going to be x plus 7 times x minus 3 equals 0. And then from here, if we wanted to solve this, we would just set each factor equal to 0. So if we set this equal to 0, then we get x equals negative 7. And if we set x minus 3 equal to 0, then we get x equals 3. And then those are our two solutions. That's one way that we could solve this. Another way we could solve it is using Desmos. So if we go to Desmos here and graph it, we can see it's already graphed here. All we would need to do is see where the graph intersects with the x-axis, and we can see that that's at x equals 3 and x equals negative 7. So then those would be our solutions. A third way that we could solve this is by using the quadratic formula. So what we would do here is plug in our a, b, and c values into this equation and then simplify from there. So let's try that. We can see that our a value here is going to be 1 because that's the coefficient of x squared. Our b value is going to be 4 since that's the x coefficient. And our c value is going to be negative 21. And if I plug those into my quadratic equation, I'm going to end up with negative 4 plus or minus the square root of 4 squared minus 4 times a, which is 1, times c, which is negative 21. And all of that over 2 times a, or 2 times 1. Now I'll simplify this, and I end up with negative 4 plus or minus the square root of, in this radical we're going to have 16 plus 84, which is going to be 100, all over 2. We know that the square root of 100 is 10, so we get negative 4 plus or minus 10 over 2, which is, it's going to give us two solutions, right? We get one solution when it's negative 4 plus 10 over 2, and one when it's negative 4 minus 10 over 2. So we have this and also this, and then we can simplify it and we get x equals negative 4 plus 10 is 6, and then over 2 is 3. And for this one, negative 4 minus 10 is negative 14, and then over 2 is negative 7. So our two solutions are x equals 3 and x equals negative 7, and we got the same solutions through factoring and graphing. So you might ask, why would we use this when we could just factor or graph, and those other ways are much easier. But in some cases, you won't be able to factor your quadratic equation, and sometimes you won't have access to a graphing calculator. So it's good to know that you can also use this method. Let's take a look at another example. Let's say we have the quadratic equation 3x squared plus 6x plus 10 equals 0. And we want to solve this using the quadratic formula. So again, we're going to plug in our a, b, and c values. Remember, this is our quadratic formula. In this case, our a value is going to be 3, b value is 6, and c value is 10. So if we plug those in, we're going to end up with x equals negative 6 plus or minus the square root of, I realize my 6 looks like a b, negative 6 plus or minus the square root of 6 squared minus 4 times a, which is 3, times c, which is 10. All of that over 2 times a, or 2 times 3. Now I can simplify this, and I end up with negative 6 plus or minus the square root of 36 minus 4 times 3 times 10 is 120, so 36 minus 120 over 6. And 36 minus 120 is going to be negative 84. So we end up with negative 6 plus or minus the square root of negative 84 over 6. And now let's see if we can simplify the square root of negative 84. Now obviously that's not going to be a real number, but we may still be able to simplify it. So if we think about factors of negative 84 that are perfect squares, let's see, is 16 going to be a factor? Let's check. No, 16 is not a factor, but we should just be able to use 4. So 84 divided by 4 is 21. So what we could do here to simplify, if we just had the square root of 84 and we wanted to simplify this, we could say that 84 is equal to 21 times 4. And then this would simplify to root 21 times root 4. Root 4 is 2. So we end up with 2 times root 21, and that's a simplified form. But we don't have the square root of 84. We have the square root of negative 84, right? So the way that we're going to simplify this is almost in the exact same way, except it's going to end up being 2i root 21. Since this is a negative square root, it is going to be an imaginary number. And then this is all going to be over 6. Now I can split this up into my two solutions, and I end up with negative 6 plus or minus 2i. Sorry, first solution is going to be negative 6 plus 2i over root 21. Sorry, I said that wrong. Negative 6 plus 2i root 21 all over 6. Second solution is negative 6 minus 2i root 21 all over 6. Okay, those are our two solutions. And notice how in this case, our solution was actually an imaginary number or a complex number, right? So we don't always get real solutions when we solve quadratic equations. And in this case, since we have an imaginary number as our solution, that means that this quadratic equation never actually intersects the x-axis. So let's go ahead and graph that so we can test that. if we graph 3x squared plus 6x plus 10, we can see that the graph never actually intersects the x-axis. So that's why there are no real solutions for this case, and instead we have two imaginary solutions. Let's keep going. Also, one thing I wanted to point out before we keep going is that notice how we had no real solutions in this case because the number inside our radical was negative, right? In the previous example, we had two real solutions because the number inside our radical was positive. So keep that in mind because we're going to come back to that later. Let's look at one more example. Let's say we have negative x squared plus 10x minus 25. And we want to solve this using the quadratic formula. So again, our a value is going to be -1 in this case because that's the x squared coefficient. B value is going to be 10 and C value is going to be -25. So if we plug that into our quadratic formula, we end up with -10 plus or minus the square root of 10 squared minus 4 times a, which is -1, times c, which is -25, all over 2 times a, or 2 times -1. Now, if we simplify this, we get -10 plus or minus the square root of 10 squared is 100. And this part here is going to be 4 times -1 times -25 is going to end up being positive 100. But we also have this minus sign out here, so then that's going to be 100 minus 100 all over 2 times -1 or -2. Now notice how inside this radical, that's just going to be 0, right? 100 minus 100 is 0. So we have -10 plus or minus the square root of 0 over -2. And the square root of 0 is just 0, so we end up with -10 plus or minus 0 over -2. And if we split this up into our two solutions, we're going to end up with -10 plus 0 over 2, or sorry, -10 plus 0 over -2, and -10 minus 0 over -2. And if we simplify these, we get -10 over -2 and -10 over -2, or 5 and 5. So notice how our two solutions are the same thing, right? So in this case, we only end up with one solution. It is a real solution, but we only got one solution. And if you were to graph this and solve it, you would notice that the graph only intersects the x-axis at one point. That's why we have one solution. So let's go ahead and graph this and see what happens. We get -x squared plus 10x minus plus 10x minus 25. And we can see that it only intersects the x-axis at one point, which is 5. And notice how we got one real solution when the number inside our radical was 0. We got no real solutions. We got two imaginary solutions when the number inside our radical was negative. And we got two real solutions when the number inside our radical was positive. So let's talk now about the discriminant. So I pointed out before that the number of solutions that we get really depends on what the number in the radical is, right? So if we write our quadratic formula one more time, I'm going to simplify this a little bit. I'm going to come up with a simplified example just to reiterate the point. Let's say that we have 1 plus or minus the square root of some number. And I'm going to write this 3 times. First, let's say that we have 1 plus or minus the square root of a positive number, like 36. Now, in this one, I'm going to put 0. And in this one, I'm going to put negative 36. In the first case, when we have 1 plus or minus the square root of positive 36, we end up with 1 plus or minus 6, right? Which becomes two solutions, right? 1 plus 6 and 1 minus 6. In the second case, we have 1 plus or minus the square root of 0, which is just 1 plus or minus 0, which is just 1. So we end up with one solution. And in the third case, we end up with 1 plus or minus 6i, or 1 plus 6i, 1 minus 6i as our two solutions. So two imaginary solutions. And that isn't by accident. So this is something that's always going to happen. Whenever you have a positive number inside your radical, you're going to end up with two real solutions. Whenever you end up with a 0 inside your radical, you're going to end up with one real solution. And whenever you have a negative number inside your radical, you're going to end up with two imaginary solutions, or in other words, no real solutions when you have a negative number inside your radical. So the number inside this radical is important because it tells you how many solutions your quadratic equation is going to have. And you can see that the number inside the radical is b squared minus 4ac. That's the value of the number inside the radical. And that is called the discriminant. So to formalize this, the discriminant is equal to b squared minus 4ac, and when it's greater than 0 or positive, you have two real solutions. When it's less than 0 or negative, or actually let me do when it's equal to 0 first. When it's equal to 0, you're going to have one real solution, and when it's less than 0 or negative, you're going to have no real solutions. And you're going to have two imaginary solutions. So this is a really important thing to keep in mind for the SAT. You'll often see questions where it says, how many solutions does this quadratic equation have, or some variant of that question. So keep this in mind, that whenever you want to know how many solutions a quadratic equation has, you're going to refer to the discriminant. One more thing I wanted to go over was, actually before we go over that, I'm going to do one more example. Let's say I have the quadratic equation negative 3x squared plus 12x plus 1. And I wanted to know how many solutions does this quadratic equation have. Now, one way that I could go about doing this is solve the entire equation, but that might take some time. And if I want to only know, how many solutions does this have, there's an easier way I could do that, which is just by using the discriminant. So what I'm going to do is find the discriminant of this, and remember the discriminant is the value inside the radical, or in other words, b squared minus 4ac. So I'm going to find b squared minus 4ac, and I know that if that number is positive, I have two real solutions. If it's 0, then I have one real solution, and if it's negative, I have no real solutions. So my b value is 12, so I'm going to have I'm going to have 12 squared minus 4 times a, which is negative 3, times c, which is 1. Now if I simplify this, I end up with 144 plus 12, because these two negatives are going to cancel out. And 144 plus 12 is 156. We can see that that number is positive, so we're going to have two real solutions. So that's one way that you can use the discriminant. Now I'm going to go over one more thing before we look at some SAT practice problems. Notice how when you solve, if we go back to our previous examples, notice how when you solve a quadratic equation using the quadratic formula, your answer comes in this general form, where you have some number plus or minus a radical all over another number. if we look at this one, we had the same thing. Before we simplify, at least, this is what the general form of our solution looks like, right? Some number plus or minus a radical all over some other number. And again, in this case. That's one way that it could appear. Another way is it could just be something like this, right? Let's say that we have -4 plus or minus the square root of 2. You might not have the denominator. It might not be a fraction. It could just appear like this, right? This is another form of solution that the quadratic equation sometimes gives. So it's important to just be able to recognize that form, and you'll see why in a few minutes. But just keep in mind that this is a general form of a quadratic equation solution. It's going to look something like this. Now let's take a look at some actual SAT practice problems. Let's start with this one. It says, in the given equation, k is an integer constant. If the equation has no real solution, what is the least possible value of k? So two things that you should note right off the bat. First is, this is going to end up being a quadratic equation. Once you multiply this out, if you distribute this x, let's do that first actually. X times kx minus 56 equals -16. If we distribute this x, we're going to end up with kx squared minus 56x equals -16. And if we add 16 to both sides, we end up with kx squared minus 56x equals 16. Sorry, this should be on the left side. Plus 16 equals 0. So all I did was I added 16 to both sides to move that to the left side. Now you can see that we do have a quadratic equation, right? We have the general form ax squared plus bx plus c over here. So that's one thing to note, is that we do have a quadratic equation, and it's talking about having no real solution. So if you remember, when does a quadratic equation have no real solution? That's when the discriminant is less than 0, because you end up with a negative number inside your radical. Just like in this example over here, we had a negative number inside our radical, right? In this case, our discriminant was -84, and since that number inside the radical is negative, we have no real solutions. Our solutions are imaginary. So if we go back here, we know that our discriminant is going to be less than 0 or negative, right? And our question is asking, what is the least possible value of k? So a good first step in this case is to just find the discriminant of this equation here, and then set it to be less than 0, and then solve it from there. So let's start with finding the discriminant. Remember that the discriminant is going to be b squared minus 4ac. So we can see in this case our a value, or our x squared coefficient, is going to be k. Now although we don't know what k is, we do know that it's the x squared coefficient, so it is going to be equivalent to our a value. Our b value is going to be -56, and our c value is going to be 16. Now I'm going to plug those into the discriminant equation, and I end up with -56 squared minus 4 times a, which is k, times c, which is 16. And that's going to be our discriminant, right? And we know that our discriminant has to be negative. It has to be less than 0. So I'm going to set this to be less than 0. And now all I need to do is solve this inequality to find k. So 56 squared is going to be 3,136. And it's -56 squared, but even though it's negative, the negative sign is going to cancel out, so we're going to end up with positive 3,136. And then -4 times 16 is going to be -64. So on this side, we're going to end up with -64k, and that is going to be less than 0. Now, if I want to solve for what k is, I can add I can add 64k to both sides, and I end up with 3136 is less than 64k. And if I want to rewrite this inequality, I can write it as 64k is greater than 3136. Now what I can do is divide both sides by 64, and if I do that, I end up with k is greater than 49. So I know that if I want my discriminant to be negative, I want my k value to be greater than 49. And let's take a look at why that's true. We know that this is the discriminant, excuse me. And we can see that over here we're subtracting two numbers to get our discriminant. And you know that when you subtract two numbers, is if the second number is larger than the first number, you're going to end up with a negative number generally, right? So if we have, let's say, 4 minus 5, right? Since the second number is greater than the first number, our answer is going to be negative, right? If our first number is greater than the second number, so if we have, let's say, 4 minus 2, then we end up with a positive number. But in this case, again, we're aiming for a negative number. We want our discriminant to be negative. So in other words, we want this number, whatever this is, to be greater than this first number, right? So we want 64k to be greater than 3136. So if we plug in k equals 49, then we get 3136 minus 64 times 49, or 3136 minus 3136. And that's going to be 0, right? So that's kind of like the tipping point. When k is equal to 49, our discriminant is equal to 0. But if k is anything greater than 49, then our discriminant is going to be negative, right? So let's say I plugged in k equals 50 instead. Let's see, 64 times 50 is going to be 3200. So I end up with 3136 minus 3200. And I know that this is going to be a negative number since my second number is greater than the first number. So if I do 3136 minus 3200, I end up with negative 64, right? So we can see that as soon as k is greater than 49, our discriminant becomes negative. And that's what we want, right? Now, if k could be any number, if we go back to this inequality here, k can be any number greater than 49, right? So how do we know which one it is? It could be 50, it could be 51, 52, it could be 100 or 110. It could be anything greater than 49, right? But notice that our question is asking, what is the least possible value of k? And we also know that k has to be an integer, right? So in other words, it has to be a whole number. So that narrows it down to k has to be 50. Because although k could be 51, we want the least possible value of k. K can't be equal to 49 because it has to be greater than 49, right? And the greatest integer the smallest integer that's greater than 49 is going to be 50. So that's what our k value is going to be. Alright, let's look at the next question. It says, one solution to the given equation can be written as 1 plus root k, where k is a constant. What is the value of k? Now remember how I said that whenever you see this form, you should immediately recognize that this is the general form of a solution given by the quadratic equation. You're not going to get this solution by factoring or by graphing using a calculator. You get this solution when you solve using the quadratic equation. So that's what we're going to do. We have x squared minus 2x minus 9 equals 0, and we're going to solve this using the quadratic equation. So just a reminder, this is a quadratic equation. In this case, our a value is going to be 1, our b value is negative 2, and our c value is negative 9. So I'm going to plug those into the quadratic equation, and I end up with negative b, or negative of negative 2. Negative of negative 2 is just going to be positive 2. So I'm going to have 2 plus or minus the square root of negative 2 squared minus 4 times a, which is 1, times c, which is negative 9. All of that over 2 times 1. Now, all I have to do is simplify this, and I'm going to get 2 plus or minus the square root of negative 2 squared is positive 4, and then minus 4 times 1 is 4, and then 4 times negative 9 is negative 36, so I'm going to have 4 minus negative 36 all over 2, and 4 minus negative 36 becomes 4 plus 36, or 40, so I end up with 2 plus or minus root 40 over 2. And now I have two solutions, 2 plus root 40 over 2, and 2 minus root 40 over 2. Now notice how these two solutions look similar to this, but it's not exactly in this form, right? There's a couple things we need to deal with. First is that if we want it to be in the form 1 plus root k, we have a 2 here, right? So that's an issue. Another issue is that we still have this in fraction form, right? So I want to simplify this so that it's not a fraction. First, I'm gonna erase this one here, because we don't need this solution since we know that our solution involves addition, not subtraction. So I'm going to erase this one, and I'm just going to focus on this one. I'm going to move this over here. I have 2 plus root 40 over 2, and one thing I can do to simplify this is I can just divide both of these terms on the numerator by 2, since that's on the denominator. And I'm going to end up with 2 over 2 plus root 40 over 2. And now, 2 over 2 is just going to be 1. And over here, I'm going to have root 40 over 2. Now I'm closer to getting it to be in this form, since I have this 1 here. I have that locked in. The only issue is that in their form of the solution, they have just a radical, right? They don't have radical over 2. So we need to solve that. We need to get rid of this fraction. And here's how I can do that. I'm going to simplify this radical here. So I have root 40 and I want to simplify it. We know that 40 is equal to 4 times 10, right? So if I break this up into two numbers where one of them is a perfect square, I get 4 times 10, and I can break that up into root 4 times root 10, which is 2 times root 10. So in other words, root 40 is equivalent to 2 times root 10. Now what I can do is replace root 40 with 2 root 10, and I end up with 1 plus 2 root 10 over 2. And I can cancel out the 2 on the numerator and denominator, and I end up with 1 plus root 10, which is in the form that they wanted us to have it. They wanted 1 plus root k, and we have 1 plus root 10, so the forms match exactly, and I know that my k value is going to be, my k value is going to be 10. So that's going to be our solution. And you can see that 40 is also a solution here. 40 is one of the answer choices. And you might have picked that answer choice wrong if you stopped at this point. But remember that this solution, or this form of the solution, is not exactly matching their solution yet. So you need to make it match exactly and then take your k value. Let's look at 2 more problems. This one says, in the equation above, t is a constant. If the equation has no real solutions, which of the following could be the value of t? Again, this is almost exactly like this first one that we did. We're presented with a quadratic equation, and we're told that it has no real solution. So remember, that means that its discriminant is going to be negative. So let's take this first. We have 2x squared minus 3x equals t. First step is we're going to convert this to be in standard form for a quadratic equation. So that's going to be 2x squared minus 3x minus t, if I subtract both sides by t. Now what I'm going to do is find my discriminant. Remember, discriminant is b squared minus 4ac. And in this case, our c value is just going to be t. Since again, or actually it's going to be, let's see, let me write this in a better form. I'm going to rewrite this slightly. I'm going to write this as minus 3x plus negative t, just to match it to the general form of a quadratic equation closer and make it more obvious what our a, b, and c values are. So we can see that our a value here is going to be 2, our b value is negative 3, and our c value is going to be negative t. Again, we're told that t is a constant, so it is just going to be a constant number, and we're going to use that as our c value, but it is going to be negative t in this case, since that's what matches our quadratic, our general form for a quadratic equation. So now that we know our a, b, and c values, I'm going to plug those into the discriminant formula, and I get b squared, or negative 3 squared, minus 4 times a, which is 2, times c, which is negative t. And if I simplify this, negative 3 squared is going to be positive 9, and then minus 4 times 2 is going to be 8, and 8 times negative t is going to be negative 8t, so I have 9 minus negative 8t. And 9 minus negative 8t is just going to be 9 plus 8t. So that's my discriminant. Now what I'm going to do is set this to be less than 0, because again, we want no real solutions, so that means our discriminant has to be negative. And we're pretty much going to do the exact same thing as before. We're going to solve for t, so I'm going to subtract both sides by 9, and I get 8t is less than negative 9. And divide both sides by 8, and I get t is less than negative 9 over 8. So we can see that t has to be less than negative 9 over 8, and it's saying that t is a constant, and I'm going to assume, it doesn't say here, but you know, based on our answer choices, I'm going to assume that t is going to be an integer or a whole number. So what is and actually it doesn't say like what is the smallest value of t or anything in this case, it just says which of the following could be the value of t. So what I'm going to do actually here is I'm going to take our inequality up here and see which one of these answer choices satisfies it. We know that it's definitely not going to be C or D, because 1 and 3 are both positive. They're not going to be less than negative 9 over 8. Negative 1 is also not less than negative 9 over 8, right? If you convert negative 9 over 8 to a decimal, it would be negative 1.125, right? So negative 1 is slightly larger than negative 1.125, so that's not it. So then our only remaining answer choice is going to be A. Negative 3 is less than negative 1.125. And if we were to, let's say we wanted to check our answer, right? I'm going to go ahead and graph this, right? We have 2x squared minus 3x plus negative t. If our t value is equal to negative 3, negative t would be equal to negative of negative 3 or positive 3. So then our final quadratic equation is going to be 2x squared minus 3x and plus 3. Now what I'm going to do is go ahead and graph that so that we can see. Remember that we should have no solutions, which means that this quadratic equation should not intersect the x-axis at all. So I'm going to have negative 2x squared, so positive 2x squared minus 3x plus 3. And we can see that this quadratic equation does not intersect the x-axis, so there are no real solutions. Now, if I revisit this problem, but let's say that it asks for, instead of no real solutions, let's say I wanted one real solution, right? If we go back here, we know that when the discriminant is equal to 0, we have one real solution, right? So let's go back and see if we can make this have one real solution. If we go back here, remember that the discriminant is equal to 9 plus 8t, right? Before, I set this to be less than 0 since I wanted a negative discriminant, but now I want a discriminant that's equal to 0, so I'm going to set this equal to 0 and solve for t. I get 8t is equal to negative 9, and divide both sides by 8. T is equal to negative 9 over 8. Now if I plug that in to my quadratic formula, remember that we have 2x squared minus 3x plus negative t. So if our t value is equal to negative 9 over 8, we're going to take negative of negative 9 over 8 or positive 9 over 8. So our quadratic equation is going to be 2x squared minus 3x plus 9 over 8. If I go ahead and graph that, this should have one solution, which means that it should intersect the x-axis at exactly 1 point. And we can see that it does. We have one solution over here. And if you wanted to do the same with, two real solutions, all we would need to do is set the discriminant to be greater than 0 or positive, right? And we get 8t is greater than negative 9. T is greater than negative 9 over 8. So any t value that is greater than negative 9 over 8 should give us two real solutions. So let's say I use a t value of 0, right? That just means that, we have 2x squared plus 3x plus 0. And if I graph that, we can see that our graph now intersects the x-axis at 2 points. So we have two real solutions. Let's do one final problem. If 4x squared plus bx plus 9 equals 0, where b is a constant, this has exactly one solution. What is a possible value of b? So again, this is going to be the exact same thing as the previous problems. We have a quadratic equation. We're told that it has one solution, so we want to solve for the discriminant where it's equal to 0. Remember that when the discriminant is equal to 0, we have one real solution. So remember, the discriminant is equal to b squared minus 4ac. In this case, our a value is 4, b value is b. So I end up with b squared. It literally is just b squared since that's what our b value is. And then minus 4 times a, which is 4. Let me write this a little neater. Times c, which is 9. So we have b squared minus 4 times 4 is 16. And let's see, 16 times 9 is 144. So I have b squared minus 144, that's my discriminant, and I want this to be equal to 0. So, because again, I want one real solution. So all I need to do is solve for this, and I get b squared equals 144. If I take the square root of both sides, I get b equals plus or minus 12. So two potential solutions are b equals 12 and b equals negative 12. Let's see. It looks like that's gonna be over here, right? So answer choice C is b equals 12, and that's going to be our answer choice. So that's the quadratic formula in discriminants. Remember, these 4 problems I would say are some of the most common that you'll see on the SAT. And two things that you need to recognize is that whenever you're dealing with a question that has a quadratic equation and it asks you, there's one real solution or no solutions or two real solutions, that's dealing with the discriminant. And whenever you're dealing with something like this where it says that the solution is in this form, like 1 plus root k, something like that, that's generally dealing with a quadratic formula. So just make sure that you're able to recognize those patterns on the SAT.